This is the lesson for Chapter 3, Section 7, Absolute Value, Equations, and Inequalities. And this is the second day, and so first day we ended up just doing equations, but now we're going to focus on inequalities. And so when we're dealing with inequalities, we have to look at that inequality sign to determine which way we're going to end up, or what kind of absolute value inequality we're dealing with here. So the first step I always do is isolate the absolute value. And so I'm going to go ahead and add this 8 to both sides. And once I do that, I still have a 7. And I have a 3y minus 4. The absolute value of that is less than or equal to 40. And so from this point, I need to divide by that 7. So this is going to be kind of an ugly problem because 7 doesn't go into 40 quite evenly. So what I'm going to do is I'm just going to leave it like this. 3y minus 4 inside some absolute value bars is going to end up being, let's see here, I see where a mistake is there, so let's go ahead and fix that real quick. So I'm going to go ahead and I had to add, so I must have been thinking of subtraction as I was doing that problem. So let me go ahead and fix this real quick. So I see that I have to add 8 to 48, and when I add those two numbers I do get a value. Looks like it's going to work out a little bit better. That makes 56, and I like this problem a whole lot better now because I don't have that fraction to deal with. 7 does go into 56, goes in there 8 times. And so again, I added the 48 and the 8 together, 56, and then divided by the 7, and I'm getting 8. So at this stage, what I'm going to do is I'm going to look at the inequality. So I always isolate the absolute value first. Then I look at this inequality. And so when I look at that, that says less than or equal to. Less than. And then it does say or equal to. And when I look at that, the key is this less than. And so one way to think about this is to kind of modify this word than and change that to than, and that tells me, oh, even though that's not a word, that is the type of statement I'm going to end up seeing there. So whenever I have a less than symbol, that tells me it's going to end up being an and statement. So that means the values are between numbers. And so that's what I'm going to end up looking for. And so right away, when I see that less than or equal to, again, you got to solve the absolute value for a number and then determine what kind of inequality sign you have. When it's a less than, it's always going to end up being an and statement. So the values are going to be between two numbers, 8 and negative 8. So when I go ahead and add the 4 to all sides, I end up with a negative 4 is less than or equal to 3y, which is less than or equal to 12. And so I'll divide by 3, and when I do that I get a fraction here of negative 4/3 is less than or equal to y, which is less than or equal to 4. So if I was to graph this, negative 4/3 or negative 1 1/3 would be on the left hand side. 4 would be on the right hand side. It'd be closed circles on these, and you see how the values y is greater than or equal to the negative 4/3 but less than or equal to the 4. So that's why it's an and statement. So on the next one though, we see that the absolute value is already isolated. And so what we're going to end up having here is a different symbol. It's a greater. But rather than think of it as greater, I'm going to change that E to an O, and I'm going to call it greater, because whenever I have a greater than symbol, that tells me it's going to be an or statement. So it's just a little way of helping us remember how that works. And so now 3c minus 4 needs to be greater than the positive, but less than the negative. See, that's why it's going to be an or statement. So when we go ahead and solve this, I just do those opposite operations. I'm going to add 4 to all sides. And I end up here with a negative 8 is greater than 3c, which is greater than 16. So when I go ahead and divide by 3, well, 3 is not going to go into that 16 evenly. So I'll just change these to mixed numbers, make it a little bit easier for me to understand. So c is greater than, and then 3 goes in there 5 times with 1 left over. And then it's also going to be less than negative 8/3, which is the same thing as negative 2 and 2/3. So since this is an OR statement, you can see it because C is less than the negative. I'm going to rewrite this as an OR statement. C is less than negative 2 2/3, or C is greater than, make that a nicer C there, C is greater than 5 1/3. So this is an OR statement, and whenever it's a greater, it's going to be an OR statement. And I have negative 2 2/3 on one side. I've got the 5 1/3 on the other. And it's an OR statement, means C is going to be bigger than the positive, but less than the negative. So that's something to remember. These are just little sayings to help us remember whether it's an AND statement or an OR statement. Whenever it's less than, it's going to be an AND statement. Greater is going to be an OR statement. So less than, greater might help you remember those things. Let's take a look at a couple word problems and see what they ask for. It says, in a child takes a nap averaging 3 hours and gets an average of 12 hours of sleep at night. Okay, so the nap is averaging 3 hours. Sleep at night, 12 hours. So it says nap time and nighttime sleep can vary between 30 minutes. Okay, so what are the possible lengths of time the child's nap and the nighttime sleep? So we got two inequalities we're going to end up setting up. Now I know this is going to be an AND statement because it says they can vary by 30 minutes. So vary by 30 minutes means it could be plus or minus 30 minutes. And so plus or minus 30 minutes, since we're dealing with hours here, I need to change this to hours. So this is the same thing as plus or minus 1/2 hour. And I'm going to end up using this number instead of the 30 minutes. So the way I'm going to set it up is this. I've got my nap time, and we set it up this way. X minus, X is the amount of sleep. So X equals sleep in hours. And so we're doing X minus 3. So I always start with the number that is that it's of at least 3 hours of sleep at for the nap time. And then I'm going to set it less than or equal to, because it can vary by 30 minutes, less than or equal to 5/10. And then I'm going to also do for the nighttime sleep. So we've got X, the amount of sleep in hours, minus 12, the absolute value of that, and then I've got less than or equal to 0.5. And so again, it's less than or equal to because it's plus or minus, so it's going to add 12 to it, subtract 12, so it's going to be in between two values. So that is those are the absolute value inequalities set up. So to solve them, all I do is just do an opposite operation. Set X minus 3 less than or equal to 5/10, and set X minus 3 less than or equal to negative 5/10. And so when you add the 3 to all sides, that's how I'm getting those values. So I've got 2.5 hours here, and I've got on this other side 3.5 hours. So there's the first one for nap time. And for the nighttime sleep, same sort of thing. X minus 12 is less than or equal to 5/10, greater than or equal to negative 5/10. So when I add the 12 to every side to get the X by itself, I get the values of negative 11 5/10. Actually not negative, because it is more positives than negatives. So we'll change that sign. Doesn't make sense to have negative hours of sleep anyhow. And then X is less than or equal to 12.5. So that's the absolute, that's the what are the possible lengths of time? So X is in between these two values, and X is in between these two values for nap time. And then they also asked for the inequality, or to write an inequality. So in a sports poll, 53% of those surveyed believe that their high school football team will win the state championships. The poll had a margin of error of plus or minus 15. So this tells me I'm between values. And so when I'm between values, that tells me what kind of absolute value to use. I use less than because that's an AND statement. So it's 5% percentage points. So we're going to use percentage values here. So we're going to write and solve an absolute value inequality to find at least the the least and greatest percent of the people who think their team will win the championship. So we're going to set it up this way. So we've got x equals the percentage. Oops, let's change that to percentage. Percentage believing their team wins championship. And then we'll set it up. So we've got a x minus 53 inside some absolute value bars is going to end up being less than or equal to 5% in this case. So I just set it up that way, x minus 53 less than or equal to 5, but greater than or equal to negative 5. So when I go ahead and add the 53 to all sides, that's going to give me my values. So we end up with a 48. It's the low end of average, and the high end of average is 58. And these are percentages. So there we have it. The possible values here, x is in between these two numbers, 48% and 58%, and everything in between. And here is the absolute value equation, or inequality in that case. So those are the types of problems you're going to see on tonight's homework. Good luck.